All right, well, everybody, welcome back to our statistics class notes. We're in the last video here for section 7.4 and the last video for chapter 7. So we're on page 111, about halfway down, and we're going to do two more examples. Example 140, a political consultant randomly surveys 500 voters in a district to see how many intend to vote for a certain candidate. Of the 500 voters surveyed, 265 indicate they will vote for the candidate. So we did a sample of 500 as political consultant, and 265 of them, which is more than half, right, said that they're going to vote for the candidate. Now, using a 99% confidence interval, should the consultant predict that the candidate will win the election, and why or why not? Now remember, to win the election, you just have to have a simple majority, more than 50% of the votes, which he has in the sample. So let's go ahead and look through that. First of all, that's a sample of 500. Doesn't indicate that there wasn't a vote. It's not everybody in the district. So I'm trying to get you to understand that even though our sample says more than 50% are going to vote for this person, it's not. We have to be very careful about whether we can be confident that our candidate here is still going to win. So first we verify the conditions of the central limit theorem. One, random and independent sample is assumed, of course. Okay, and then we have to have a large enough sample, so we need the number of successes, or the number of people who said they were going to vote for the candidate, which would be n times p hat. So p hat is this 265 over 500. But again, if I have the sample and I know exactly how many said yes, I don't need to do this formula because I know it's 265. Certainly bigger than 10. And the other remaining people out of the 500, which would be 235, is also bigger than, that should be 10, sorry, bigger than 10. So in other words, that's a large sample. And the second thing is that, or the last thing is that the population is bigger, at least 10 times bigger than our sample. 10 times our sample is 5,000. I think it's reasonable to assume that the population of all voters in the district is more than 5,000. Okay, so we're going to use StatCrunch one more time. I'll do it again just to show you one more time. We have to put in the number of successes, which was 265, and the number of observations, which is 500, the sample size, and the confidence level of 0.99. Let's do that real quick. Go to StatCrunch. Remember, we do this by going to Stat, Proportion Stats, one sample, and we don't have the data like you do with your projects, so we just have the with summary. So go to a summary. Put in the number of successes, which is 265. Number of people who said they would vote for the candidate. The number of observations is the sample size, 500, and we want a 99% confidence interval. Oops, got to change it to confidence interval, and then 99%. Okay, so hit compute, and all the information is right there. We got our sample proportion. Our 265 out of 500 comes out to be 53%, which was our sample percentage. Standard error. Most importantly, our lower limit is from 0.4725 or 47.25% to the upper limit of 58.75%. Okay, so let's go back to our notes. And I put those proportions right here for our confidence interval, p hat minus m to p hat plus m, the lower limit to the upper limit. Okay, so the way we summarize this is we say we are 99% confident that the percentage of all voters in the district who intend to vote for the candidate is somewhere between 47.25% and 58.75%, the lower limit and the upper limit of our confidence interval. So since the confidence interval contains values less than 50%, that means our true population proportion could very well just as much be below 50% as it's above 50%. So we should not predict that the candidate will win the election. And as the last example, example 141, according to housingwire.com, 93.8% of homeowners had positive equity in their homes. Suppose that the margin of error is plus or minus 3 percentage points with a confidence level of 95%. So let's state the confidence interval in interval form. So what we have is our sample proportion, or in this case I'm going to write it as a percentage. Sample percentage is 93.8%. We had 93.8% of homeowners having positive equity. The margin of our error, however, is 3%. So we have to subtract 3% and add 3%. That's what they mean by saying plus or minus 3 percentage points. So when you subtract 3%, you get 90.8%. You add 3%, you get 96.8%. So we interpret this by saying we are 95% confident that the percentage of all homeowners that have positive equity in their homes is somewhere between 90.8% and 96.8%. And we have finished chapter 7.